Hi, welcome back to Moose in Chemistry. This is an electron configuration of Lutetium LU lesson. So, LU, Lutetium, I hope I'm saying that right, is element number 71, okay? So we're going to put down the atomic number of 71. Okay, awesome. All right, there's our 71. And our atomic mass number is going to be 175. Okay, so that means we have 71 protons, and since it's electrically neutral, we have 71 electrons. And our neutrons, we're going to have 104. And we're going to have that number. We take 175 minus 71 to get 104. Okay, now, with that in mind, we're going to also look at some other cool things here. Okay, so remember that when we do our electron configuration, that the S can hold 2 electrons, the P can hold 6 electrons, D can hold 10 electrons, F can hold 14 electrons. And we're going to use the off-ball principle, which states that we have to fill the lower shells first before we fill the upper shells. And we're going to use the diagonal rule, and I'm going to start off here at the top of this diagonal rule here by putting in an X right here. And we're going to slide down these slides until we run out of electrons, which is going to be 71 electrons, right? So 1s2, 2s2, okay, 2p6, 3s2, 3p6, 4s2, pretty darn amazing, huh? 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, 5d1. Yes, pretty darn cool. All right, now we're going to do the orbital notation, which is Hund's rule. Hund's rule says that you have to put an up arrow for every suborbit before you start that down arrow of that suborbit. So just watch and see. Up arrow, down arrow. Pretty cool, huh? Up arrow, down arrow. Here's where the classic is. 2px, 2py, 2pz. Up, up, up. You put an up arrow in every suborbit before you start that down arrow. That suborbit. See? Down, down, and down. That's Hund's rule. Hey, hey. Pretty simple, huh? 1, 2. And we're just going to go through here. And again, just take your time. Make it look good. You know, this is stuff that you can have like a lot of fun with your friends. Think on a weekend, hey man, what are you going to do? Hey, let's do some Hund's rule electron configuration. Those are the cool friends, man. I'm going to tell you, that's the absolute cool friends. Or as we say, snarly, which is the new form of cool. So 1, 2, 3. As you're talking, make sure you don't make mistakes. All right, here we go. 5s up and down. Here you go. See how easy this is? I mean, this is just as simple as can be. And how many arrows should you have? Boy, we're going to have 71 arrows because we have 71 electrons. An arrow represents an electron. That's right. All right. I know I'm stalling here, just trying to finish this up. Okay, we're getting pretty close now. And then we're going to do our down arrows. And then we have one up arrow right here. Okay, now, what about our noble gas notation? Well, our nearest noble gas, you can't do the one after Lutetium, you have to do the one before. So the one before is xenon. Okay, and xenon ends in 5p6, right? So come over here. 5p6, and of course we're going to box that all in. So the purpose of noble gas notation is to kind of like shortcut all the work, right? So you write Xe in there, and then we go 4f14, 5d1, 6s2. Now, quantum numbers using Pauli exclusionary principle says that no two elements and have the same set of quantum numbers? Okay, Lutetium looks like it's in the 6th period, but it's actually not, because it's in the D block, so it's n minus 1, so it would be 6 minus 1, which would be 5 in this case. So the energy level is 5. The angular momentum number, since it's in the D block, is going to be 2, and it's the first one in the D block, so it's going to have a negative 2. And that last arrow right here is going up, so it's going to be 1/2 positive. That's right. So that's it for this lesson. You guys be snarly, which means cool, by the way. And we'll see you back here at Musin Chemistry.